Okay, we are doing 1.7. If you look at the textbook, you all have a textbook, you can see all of those things. So this is a review of interval notation and then also set builder notation. Have y'all seen this before? Yeah? Okay. So whenever we do inequalities and absolute value inequalities or absolute value equations, we can set it up where we're representing it as in between two numbers. So all of these, closed interval, open interval. So this is just a review. Y'all should know these. If you want to write it down, you can. I've written this down, and maybe I'll just upload a picture on Google Classroom. So y'all will just have this to look back on if you need it. So interval notation between A and B, where it's a set of A, and then this line right here means such that A is less than X is less than B. So parentheses means A and B are not included. So we could have it as parentheses, or we can have it as open and closed circles. So I'll upload a picture of this. So I'm just going to go over it. You don't have to write it down. I'll upload the picture so you can look back at it, because this will take quite a bit, and I don't want to take up that kind of time for writing this down. So I'll just go over it. The closed interval means we are going to use brackets. That means that A and B are included. So we have the set X such that A is less than or equal to X is less than or equal to B. So it goes from A to B. Since we're using the less than or equal symbol, we would include it. So we can do brackets, or we can do circles. Infinite intervals are where it goes on and on forever in one direction or the other. So if it's A to infinity, that means it starts at A and goes on and on to infinity. So X such that X is greater than A. But if we have a bracket or a closed circle, X would be greater than or equal to A. So it goes on and on forever in the positive direction. And then we have negative infinity to A. That means it goes on and on to negative infinity. So it goes to the left. And it starts at A and goes left. So left, it always deals with being less than. X is less than A. Then if we have less than or equal to A, then we have the bracket. And then an infinite interval where it includes all real numbers is where it goes from negative infinity to positive infinity. So an example would be this. Negative infinity, 4. So we have the parentheses. So that means negative 1 is not included, but 4 is. So X is between negative 1 and 4. So we put a parentheses here and a bracket here. And then it can go the opposite way also, where the brackets with the first number, if it's included in, so you have the or equal to here, up to 4. Okay, so like I said earlier, I'll upload that. All right, so let's get into actually solving these. So I'm going to put Google Classroom image, and you can copy this down if you want. Okay. So let's talk about unions and intersections. So A intersect B. So the upside down U is intersect. So whenever you intersect two sets A and B, It is. It includes all the elements that A and B have in common. So set of elements in common for set A and B. Okay, and then union looks like a U. Union is both sets together. So set of elements in set A or set B or both sets. So we are going to talk about how to find intersections and unions with two intervals. So the first thing you do is you graph each interval on the same number line. Two, you're going to decide whether it's an intersection or a union. So if it's an intersection, then you take the portion of the number line that the two lines have in common. And if it's a union, you're going to take the portion of the number line representing the collection of both sets. Okay, so let's do some examples of this. So the first one is parentheses 1, 4, and we are going to intersect that with bracket 2, 8. So let's draw a number line. And make sure that we can get all of these numbers on there. So it looks like we can just start at 0. 0, 1, 2, 3, 4, 5, 6, 7, 8. So 1, 4 means I'm going to do parentheses at 1, parentheses at 4, and then shade between them. So that's that one. I'm going to do it in different colors. And then I have 2, 8. So bracket at 2, bracket at 8, and then shade between them. Can y'all see that good enough? The different colors. So this one was the peach color. So let's look and see what is both. If we're doing intersection, we want the ones that they have in common. So what do they have in common? Yeah, 2. 2 what? 4 with parentheses. We can't do a bracket here because that 4 is not included on the first one. So that's why we had to stick with parentheses here. This one, it went through 2, so it's included. It's included in both of them. So that's why we were able to include it in the intersection. Okay, let's do number 2. Now let's do the union of them both. 1, 4, union 2, 8. So we'll graph them again. So 1, 4. And then 2, 8. So then what would be the union of these? We have to take the whole thing. So what's the furthest left that it goes? It's the least number. 1. And then what's the most? 8. And then we can match up the parentheses that goes with 1 and the bracket that goes with 8. So remember, union is together, intersection is both. Like how much is in common. Okay, so now let's talk about how to solve inequalities. So we're going to solve and we're going to graph them. Okay, we are going to solve the inequalities the same way we solve equations. But the only thing is you always want to have the format for the inequality should always be the variable and then the inequality sign like this and then some number. You don't want to have it like this. If you do, you just need to flip these and flip this symbol. We want it in the X inequality and then some number so that it's in the format that we need in order to graph it. And then the other thing that you have to remember, the special rule, when you're solving inequalities, anytime you multiply or divide both sides by a negative, you flip the symbol. So that would be like if we have 4x is greater than 20, negative 4x is greater than 20. This is our last step in order to solve it. You would divide by a negative 4. Anytime I do that, I try to help myself remember by circling the inequality. And that way I have x is, instead of greater than, it's now less than negative 5. So let's look at some examples. If I have 2, so example number 1 is going to be 2, parentheses x plus 4 is greater than x plus 3. So just a quick, easy one just to help remind you. Distribute it. We have 2x plus 8, x plus 3. Subtract x on both sides because your goal is to get the x on the left side. So I always try to just move whatever's on the right side, the x that's on the right, to the other side. I get x plus 8 is greater than 3 minus 8 minus 8. X is greater than negative 5. So then when we graph it, zero, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7. So x is greater than negative 5. So it's going to be a parentheses on negative 5. And we're going to go right to infinity. So I think what we had been doing before this class was putting it as an open circle. So we're just changing that to parentheses. I think that's how Pearson has it, which you can have it as an open circle on your paper because that's what you're used to, and then just turn it to a parentheses. So then our interval notation would be negative 5 to infinity. Okay, let's do another one. X plus 1 is less than or equal to x minus 1. Remember, you solve these out. We're going to subtract x. And we get 1 is less than or equal to negative 1. Is that true? No. So since that's not true, we have a no solution. But if it was true, then we would say all real numbers. So let's do, why did I put 3 here? Who knows? All right, let's do a third example. 3 parentheses x plus 1 is greater than 3x plus 2. So we distribute 3x plus 3 greater than 3x plus 2 minus 3x. 3 is greater than 2. Now, is that true? Yeah. So all real numbers. This is true. So the way we write that is the set of x such that x is an element of the real number system. And that means any number that's real could be subbed in for x and it would stand true. The interval notation of that would be negative infinity to positive infinity with parentheses around it. All right, next thing is compound inequalities. An example of a compound inequality would be like this. These are two inequalities, but what you notice about them is they both have the 2x plus 1. So we can actually rewrite this as a compound inequality. Like this. And what we want to do is we want to isolate the variable in the middle. I think you learned this in Algebra 2. Do y'all remember it? Maybe a little bit in Algebra 1, but that's been a while. Okay, so let's solve it. Whatever you do to the middle, you have to do to both sides. So minus 1, minus 1, minus 1. Negative 4 is less than 2x is less than or equal to 2. And then divide by 2. And since it's positive, that doesn't change our inequality symbol at all. So negative 2 is less than x is less than or equal to 1. So our number line, we'll go ahead and draw that. So we know we have to have -2 and we have to have 1. So I can put a 0, 1, 3, -1, -2, 3. No, we don't flip the signs because I divided by a +2. And this means that x is less than or equal to 1. So that means bracket on 1. And then -2 is less than x. Like that. So then we can write the interval notation. Parentheses, -2, comma 1, bracket. Okay, let's do another one where it's already set up like a compound inequality. I have 1 is less than or equal to 2x plus 3 is less than 11. So we know we need up to 4, 3, 2, 1, 0, -1, and down to -1. -1 is or equal to, so we're going to put a bracket there. 4 is just x is less than 4, so parentheses. And so the interval notation is bracket, -1, comma 4, parentheses. Okay, and the last topic on this section is absolute value. So the topic is solving inequalities with absolute values. So recall that the absolute value of x is the distance from 0 on a number line on the real number line. So then we would do an example where it says x, absolute value of x is less than 2. That means the distance from 0 is 2. So the way you'd write this on the number line, 0, 1, 2. So you could be above 0 by 2 or below by 2 units. So x can be anywhere between -2 and +2. And we could write this as a compound inequality with using the less than symbols and go from least to greatest on your number. So -2 to +2. X is between -2 and +2. And that could be written as the interval notation, -2, 2. But then what if we say that X is greater than 2? Absolute value of X is greater than 2. So in order to be greater than 2, then it would have to be a number that is above 2. So it's going to be -infinity to -2. So that would be -infinity to -2. And then 2 to +infinity. So this is the union of those two. It could be in one set or in both sets. So we can solve inequalities this way with the absolute value, change the absolute value inequality into a compound inequality. So let's say we have X plus 4. The absolute value of X plus 4 is less than 3. Then we would rewrite as a compound inequality. So we would rewrite it as X plus 4 is less than 3. And then on the other side, we'd put the -3, and we'd put the same symbol. So you'd subtract 4 on both sides. So -7 is less than X is less than -1. So if we have inequality, we need to be able to go -7, 6, -5, -4, -3, -2, -1, -1. So X is less than -1, so it'd go that way. And -7 is less than X. Or you could rewrite this as X is greater than -7. It's everything between them. -7, -1. What's this? Okay, so that is all your notes. I'll upload that picture, and you have a My Math Lab assignment.